Here I used a sketch, which was just an offset from the outside of the shape, and I used that sketch to pattern the feature. But notice that feature is kind of offset from the pattern, and it maintains that offset so that it's always above this line. If we take a look at the definition of the curve-driven pattern, there's a reason for that. It's the difference between the transform curve and the offset curve. Now, if I click on the offset curve, everything stays to the same side. So in this case, the top ones would come down and they go inside the curve all the way around. There's a lot of things that you can do with patterns, and in particular the curve-driven pattern. Sketch-driven pattern, you just put down a bunch of points, and it's very convenient because it's as random as you want it to be. Table-driven pattern is kind of the same thing, except you're using XY coordinates instead of points. A fill pattern, let's take a quick look at an example like that. Okay, here I've created a random curve, just a spline that encloses an area, and I filled that area with a certain type of feature. Now, if we take a look at how that works, we select the boundary, you select the feature down here, and then you tell it what type of pattern that you'd want to create. Okay, now some of these are going to depend very much on the settings. So the margin is what's the minimum distance between the feature and the boundary. This angle has to do with the sub pattern within the pattern feature. So in this case, it's a set of features, and then the next set of features is slightly offset, and so on. And they're offset at a 60-degree angle. Now we could change this to a 45-degree angle, and it would rotate that pattern slightly. Okay, that's the fill pattern. Very convenient thing for various types of situations. And then we have the variable pattern. Variable pattern I don't think is ready for prime time yet. I did a lot of examples on this, and if we take a look at this one, you know, I was trying to pattern these flower things all the way around the bottle, but what happens is, you know, at best you can get it to go around like 270 degrees, and then there's something that happens with SolidWorks and flipping planes, and you cannot get this thing to go all the way around. I simplified it to some extent, I think, on a cylinder. The variable pattern enables you to specify through a chart where you want features to be patterned around a part. The feature itself is not yet fully reliable. If you're looking to go around, say, 180 degrees on a part, you're okay. But if you're trying to go all the way around and your part is not cylindrical, the feature is probably not going to work for you. We go back to the cylindrical part. It might be that you have to be very careful about the parametric setup of how your planes work. In any case, I got it to work here on a regular cylinder, whereas you're probably not going to get it to work on a non-cylindrical part. We take a look at this again to see how the table was set up. We look at editing the table, and all we've done is done an increment on the angle, the first angle that goes around the cylinder, and then we did a second variable that positions the height, and all it's doing is rebuilding this feature at every instance on the table. So I've created a single feature and given that feature an angle around the cylinder and a distance along the axis of the cylinder. And then the third dimension here is to spin the flower incrementally so that each flower is at a different angle. And there are some other features, such as a very sketch, that you should be aware of how to make these things work. In this case, we've created a rectangle in the center and an oval on the outside, and this is all with a circular pattern using the very sketch option. Really what it's doing is driving a single feature that has parametric end conditions so that it's controlled by the outside and an inside sketch. And then it's patterning that as it goes around. That's the very sketch. I've got a couple of examples of that in here. Here's another one. Okay. In this case, it's a linear sketch, but the end conditions on these features have been altered slightly. Well, not necessarily the end conditions, because they're all just through cuts. But it's the sketch itself that has been driven by a reference sketch. Hope you enjoy. Thanks. Bye-bye.